Hello everyone, very good evening. Thank you for joining in today's session, and thank you Matt for reaching out to me to take this session. So without any further ado, let's start with the topic, the talk that we are going to have today. So we are going to talk today around Azure Web Apps. Uh, Before we jump onto that, a little intro about myself. I have around 11 years of experience, and I've been working on Azure since 2010, but my key skills include Angular, .NET, SQL, and so on. I have few certifications around Microsoft Azure. In today's talk, we will majorly cover what is app service, what is web app, what are different things we can do to monitor an web app, test a web app or scale a web app, and what are the different tools that are provided as part of Microsoft Azure Web Apps. Starting with Azure App Services, it's a umbrella service which is offered by Microsoft, which is used to deliver apps across cloud and mobile devices. For example, we can deliver cloud-based web apps, or we can also deliver mobile-based backends for the mobile apps through this offering. App services run on fully managed virtual machines, but it is slightly different from the virtual machines that we use under Microsoft Azure. We cannot do remote desktop on those virtual machines on which app services are hosted. Basically, Azure App Service is a combination of 4 different app types: web app, mobile app, logic app, and API app. Starting with web app, which we are going to cover in more detail today, it basically refers to the websites, web applications that we develop. And when we talk about specifically about web apps, it supports a variety of platforms and frameworks. It's not specifically that we have to work on .NET websites. It also supports Node.js, Java, PHP, Python, and so on. It supports web jobs, which are nothing but the long-running background tasks which we can run continuously or on demand. For example, we can run it for image processing or for processing queue messages or whatever, like order processing. It's integrated with Visual Studio, so it comes very handy for .NET developers. We can publish from websites, web apps from Visual Studio itself. We can remotely debug web apps from Visual Studio. It supports continuous integration with most of the major source control providers like GitHub, Bitbucket, Visual Studio Online, and so on. Being a part of Azure, it also supports auto load balancing. So as and when we can set up the load balancing mechanisms, and we can handle the load as and when the website grows. It auto scales. It supports geographical disaster recovery also. So if we are deploying our line of applications or line of business applications or sort of critical applications, we can go and opt for disaster recovery too. Virtual networking and hybrid connections are useful when we want to integrate web apps into our hybrid or distributed architectures. For example, I want to host my web app in Azure and I want to connect it to our SQL Server database which is hosted on premise. We can go for virtual networking or hybrid connections. Site slots for stage deployment. So it comes handy when we are deploying new versions of the web apps. So we can, rather than directly deploying applications in production slot, we can deploy them into staging slot where we can do all our automation testings and we can verify if everything works as expected and then promote them to production. And anyone who has worked earlier in Azure, they would be aware of a offering called websites. So web apps is nothing but it's been renamed from websites. Mobile apps, it is quite similar to what a web app is, but it basically provides backend services for mobile apps. We can create backends for our mobile applications. It supports more or less most of the features that are supported by web apps. Logic apps are slightly different from web apps and mobile apps in the sense that they are useful in workflows. We can define our workflows, processes into a step of actions, and we can control the flow of the process through triggers. We can trigger the process basically and handle our workflows. It is slightly, if someone has idea on BizTalk services, which are now not part of Azure, but they were initially launched in Azure. So I see it as an extension to BizTalk services. API apps refer to the REST API based service. We can expose our REST based APIs as part of API apps. It supports dozens of built-in APIs from popular software as a service vendors. And it supports Visual Studio tooling with one-click publish and remote debugging for the folks who develop in .NET. It supports create and publish custom and reusable APIs, so we can expose our own custom-built APIs to our users, to our applications. So finally, it comes into a single package. Initially, the concept was to have 4 different offerings, but they were clubbed into a single offering known as Azure App Service. So irrespective of what we create a web app, mobile app, API apps, or logic apps, it actually creates an Azure App Service. And under the hood, all the app types share the same feature set. It only differs on what we are trying to expose through our app. For example, in web apps, we expose our UI-based, front-end based web pages. In mobile apps, we expose our backend as a service. In API apps, we expose our RESTful APIs. As I said, all app types are part of Azure App Service. Each one can use the feature of the others. For example, I can have a single app service which also has a web app functionality, plus I can also expose RESTful APIs for it. All app types share the same native Azure features like Resource Manager, role-based access control. We can, whatever app we create within Azure App Service, it's considered as a resource within Azure, and we can manage that using Resource Manager templates, and we can control the access through role-based access control. When we say app, it refers to the hosting resources that are dedicated to run a particular workload. So what that means is, when we say a web app, it doesn't necessarily means that we are going to host web pages into it. It's just a reference. But otherwise, the word app refers the underhood compute resources that are going to run our workload. So if we have an application which is composed of front-end and RESTful based APIs, then we can deploy both to a single web app, or we can have one web app and one API app. The benefits that we get out of using Azure App Service is we can choose from 50+ connectors for enterprise systems and internet services, and access on-premise data using hybrid connections and virtual networks. It's part of Azure framework, which is ISO, SOC, and PCI compliant, so security and compliance is handled that way. We have an extensive list of application templates in Marketplace which we can utilize for our apps, for example WordPress, Joomla, etc. And it's for .NET developers. As I said, it has wonderful integration with Visual Studio. So it streamlines the work of creating, deploying, and debugging our app services. So before we jump onto web apps, one critical concept in app service is called as app service plans. So whenever we are creating an app service, it should be binded to an app service plan, which includes nothing but region, scale, count, like how many instances we want to have for that application, the instance size, whether it should be small, medium, large, and so on, and the SKU, which defines the pricing tier under which the resources are going to fall. So basically, it represents the collection of physical resources that we are going to specify to host our application. All applications within Azure App Service runs in an app service plan. Apps in the same subscription region and resource group can share an app service plan. The best part comes out of app service plan is we can have a single resource group in which we can define multiple app service plans, and each app service plan can have its own app, and we can use one of the app service plan and app for dev environment, another one for test, and then UAT, and then prod. And we can move applications between app service plans within same resource groups in geographical regions. I'm going to show that how we can do that, but before we jump onto a demo, it's important to understand, like, when we are going to create an app service, we are going to define an app service plan. We have an option to create a new one, or we can choose an existing service plan. So whenever we choose to create a new service plan, we should understand that the app should be resource intensive. It should have scaling needs different from the other applications. It should share different geographical region from the existing service plan. It needs a new set of resources. When I say it needs new set of resources, because an app service plan can host a multitude of apps, and each app within a service plan will share the same resources. So we might have a requirement where we might want to isolate an app within an app service plan. App service plan determines the cost and not the number of apps hosted in it. So it determines the compute resources which are billed by the Microsoft, but it doesn't care how many applications we host under that app service plan. As I said, we can create it as part of, we can create an app service plan standalone without creating an app inside it, or we can create it as part of an application also. But the point to be noted here is that even if we don't have an app service within an app service plan, there are compute resources which are logged under that plan, and Microsoft keeps billing us for that. So it's best in our interest, if we don't have any app running in our app service, then we should go ahead and delete that app service plan to avoid getting any unexpected charges. I will quickly jump onto the Azure portal to show how app service plan works. Okay. So I've logged into Azure portal. Let me quickly go and create a new app service plan. So when I create it, it asks for the subscription under which I'm going to create my app service plan. It asks for the resource group. As I said, app service plan is also part of the resource group. So we can create a new or resource group, or we can use an existing one. So I've already created one for today's demo. We can choose the operating system in which we are going to host our app service. It could be Windows or Linux. We'll opt for Windows for now. We can choose the geographical region where we want to host our app service under this app service plan. We can choose based on our requirement. In the pricing tier that you see here, we can choose the different SKUs that we want to opt for our resources. It starts from the free tier, where we get 1 gig of storage as part of the tier, but it doesn't support custom domains, and it runs on shared cores. If we want to support custom domains, we can opt for shared. Then the next one is basic, where we also support multiple instances of the app, and it supports SSL. Then comes the standard one, where we support traffic manager also. Then going forward up to the premium, it supports actually backups, traffic manager, and there is a concept called app service environments, where we can isolate our app services to run in. Those are also only supported in premium tier. So let us choose standard from now, and it's an app service plan. So, jumping onto the web apps, as I was telling before, it supports whole set of capabilities, like it supports multiple frameworks. For .NET developers, it has tools integrated within Visual Studio where we can publish and remote debug and so on. I was showing this pricing when I was selecting app service. So as I was saying, as we start from free and move towards premium, the services offered within the tier keeps on increasing, and the number of cores, RAM, storage also keeps on going. For example, in free, it's free and shared, it is shared code, whereas from basic onwards, it's independent cores that each of the app get. Now the interesting part here is that it's not standard for all the regions. For different regions, the pricing also differs. For example, if I go and select standard instance within central US region, it costs me 10 cents per hour for a standard S1 instance. Whereas if I go into Brazil South, it costs me 0.122 per hour. So before you are selecting a region or the pricing tier, it's worth trying the region which you are looking for, where your app is going to be actually accessed more. We can create web apps using command line options also, rather than only from portal, which I'm going to show it in a while. It supports complete set of commandlets like new Azure RM web app, which creates web apps under resource manager template. We need to specify the resource group under which we want to create it. We need to provide the location, the name of the web app, and the app service plan under which that app is supposed to be hosted. Different set of web apps PowerShell commands include new Azure RM web app, which creates a new web app, remove Azure RM web app, deletes a web app, set Azure RM web app. We can set different configuration settings for our existing web apps using this command. We can start, stop our web apps using start Azure RM web app, stop Azure RM web app commands. And there are a couple of commandlets for generating the publishing profile, which can be used for publishing our web apps from FTP or other sources. Similarly, Azure also supports a command line interface which can be accessed from different other operating systems like Linux or Mac. So we can create a web app using as web app create commandlet, and the parameters remains the same as it is for PowerShell. And I'm trying to show the list of the commands here from Azure CLI for web apps, which are quite similar to what we have it for PowerShell. So let me quickly go and show how to create a web app. I will go under new web plus mobile. I will create a web app. I will give the name for the web app, select the subscription under which I want to host it. I will select a resource group under which I want to host it. I'm going to select the resource group which I have created before. As I said, we can choose the operating system. It could be either Windows or Linux here. And we can go ahead and select the app service plan which we have just now created. App Insights is a monitoring tool from Microsoft, which I'm going to demonstrate after a few slides. So for now we'll keep it off. We can enable it later. So I'll go ahead and create it. So our web app is created. Starting with managing the application settings. Once our application is up, we have an option to update our application settings through the Azure portal, or we can update it through the Powershell or Azure command line interface. So here I've captured a screenshot from the portal. I will show how it looks like in portal. We can go ahead and update our app settings. We don't need to redeploy our applications again. We can directly update the settings over here. Once we save it, it will update those settings and the application will be refreshed. We can also, similarly, we can also specify the connection strings that are used in our applications in the same page. We can specify the handler mappings that we are going to use in our application. We can also create different virtual directories and applications inside the app settings folder. So that enables us to actually host multiple web applications within the same web app. We can have multiple virtual applications and virtual directories, each pointing to a different website. We can, if we, by default, when we create a web app or any app service, it comes with a default domain name from Microsoft, which Microsoft recommends that in production we should not use. We should actually buy a custom domain, which we can map it to our web apps through a custom domain setting, which I'm going to show you in a minute. We can enable HTTPS from basic tier onwards, and we can upload the SSL certificates which are binded to our custom domain through the SSL page. I will quickly show that. So if I will scroll down to on the left menu, I get a menu option called Application Settings. Here you can see the framework based settings that we can specify. For example, as of now I have just created a placeholder for my web app. I have not deployed anything, but I know I am going to deploy a .NET based application. So I really don't need PHP on my server where I'm going to run my web app, so I can actually go and turn it off. Likewise, we can change other settings. We don't need Java. If it's a Java based website, we can enable Java on the server. We can change the platform settings, sockets. We can enable always on, manage pipeline version, quite similar to how we configure our applications on an IaaS server. We can go and specify our app settings here. I can create, let's say, and I can go ahead and save that setting further. It is as simple as that. As of now, it's a blank placeholder, so I really don't have a connection string to which my app connects. But if we have a connection string, we can go ahead and add it here, or if we have added it in the web config while deploying, it will be visible here in the connection string section. We can add default documents to it, and as I was saying, we can add handler mappings, and here we can define the virtual applications and directories. We can create and provide the physical path of the files where it will point to a different site. An interesting thing I missed to update was, you can see here the slot setting. So as I was saying earlier when I was briefing about what is a web app, we can have multiple slots in which we can deploy our application, not necessarily directly deploying into production slot. So if we select slot setting, then it will apply the setting only for a particular slot rather than for all the slots. If we don't check it, then it will apply that setting for all the slots. I will save that. Web jobs, these are background long running programs that we can write down into a script, or which we can run for doing any background long running task like image processing, video processing, or if we want to read messages from queues and process them. For example, if we have an e-commerce website, we can keep on writing order messages in queue and our web jobs can keep on processing them. We can run web jobs based on demand as and when we need them. We can schedule them to run after a certain interval, or we can keep them running continuously. There is no extra cost for running web apps because they run in the same app service plan as the web app and in the same server. They support, as I said, it supports common tasks like image processing, queue processing, file maintenance, and Microsoft provides a SDK for that for Azure web jobs, which we can utilize to develop all those capabilities. And web job SDK also includes NuGet packages for decorating methods with attributes specific to web jobs, and dashboard which provides rich monitoring and diagnostics for our web jobs. I will show it in a demo. So we can run different file types under web jobs, which include command files, batch files, exes, PowerShell files, bash, PHP, Python, Node, and Java files. So basically our web app stands there, and which is a front end for our web app. Under the front end we can have multiple web jobs which might be doing different long running tasks, like they might be interacting with the queue, or they might be processing database messages or whatsoever. I will create a web app, deploy it, and deploy a web job as part of it. Then I will showcase it to you how it works. Let me quickly create a web project. I will create a web application, ASP.NET based web application. Let us use MVC template for now. And I'm going to create under the same app service plan, under the same app that I have created minutes ago. So here is my resource group where I see I have a service plan and a app service already running it there. Let me quickly run the application locally and see how it looks like right now. So I'm not touching anything for now, I'm just running a template that gets created when we create a MVC based application in Visual Studio. Okay, so if it runs fine, we'll end up into home page. We can go to about, contact, and so on. Let me quickly go ahead and publish it. When I click on publish, it gives me an option to publish it through IIS for FTP, or the first option that we get is for Microsoft Azure App Service. We can select existing. We can create a new one also from here, but let's create a new one so that I can showcase it to you. So it asks for the same options that we have seen in the portal earlier. It asks for the web app name, the subscription that I want to host it into, the resource group that we want to deploy it into, the app service plan that we want to host it into. Let's create it. It will take, okay, so it's doing it. I will go ahead and refresh my portal and I can see my new app which has come up here. But it is still deploying, so let's give it a few seconds more. So my site is up. You can see here the URL that it denotes. It's running on internet now. It's live. It says Omaha MTG test.azurewebsites.net. In the meantime, I will quickly show the I have a web job which is a PowerShell script. What it does is it just creates a text file in the folder, in the root folder in the server. So we can likewise do whatever we want to do it in our task, but just for demo purpose, I have created a PowerShell script which just creates a text file which I am going to upload it. So here is my app which is running in Azure now. Let's go to the portal. Let me refresh it. Let's go here. If you'll scroll down on the left, we'll see an option for web jobs. Let me quickly go ahead and add a web job. I will go ahead and select the web job PowerShell script that I have created. As I said, we can select, it could be a continuous one or it could be triggered. When I say triggered, it could be scheduled for a certain trigger. When I said certain trigger, it could be manual or it could be automatic. So when we make it manual, it becomes on demand. When we make it scheduled, it becomes on. When we make it triggered, we have options for either making it scheduled or manual. When we make it scheduled, it stays scheduled. It runs automatically after a certain schedule. But we can also trigger it manually. So it will always run when we come back to the portal and trigger it, or we can trigger it from PowerShell scripts or Azure CLI. So let me go ahead and create it.
So Vaibhav, what happens if you run the PowerShell script continuously? Does it just execute it multiple times?
It keeps on executing it.
So
It
just
keeps
once
on
it finishes, it just goes again.
Yeah.
Okay.
So continuously, we'll keep on continuously running it. And like for example, we have scripts which we have not only scripts but EXEs which process images. So I have seen a project where we had a queue which was monitoring the FTP files which were updated into an FTP folder. It was monitoring that, and as soon as the FTP file was updated, it used to upload it into an Azure blob storage. So in such scenarios, we have continuous, but we can have scheduled also, and we can run on demand also. So this was the web job which we just created. Let me quickly go ahead and show you how it looks like. I have a slide which covers an analysis tool or which is called as Kudu. I don't know how many of you might have heard of. I wanted to cover it later, but to showcase web jobs, I can show it to you first. So we'll discuss about Kudu later, like what all it supports, but I'm going to show you the file structure where the file is going to be created. So I'm going to create within the site root folder a file name as new_file.txt. I will go inside the site folder. Okay, so I will just do dir to see there is no file with that name. Let me go and run my web job quickly. So as soon as I run it, its status reaches running. If the script or the exe doesn't have any exceptions in there, I can go ahead and check the logs for my web app, for my web job by clicking on this logs menu. It keeps on logging how our web job has been running. If it is continuously or whatever it is, it will keep on logging what is happening. So it says it, for me it was, since it was manually triggered once, it executed 30 seconds ago and it was success. If I click on it, it shows me what it did. It started running my webjob.ps1 script with PowerShell. It identified it was a PowerShell script. It has created directory. It has reached to that root directory and created my file there, and finally it changed the status to success. So in case our web job is failing also, that exception also gets logged under these logs, and we can come back and verify what's happening if it is failing somewhere. Let me go ahead and refresh it. I will go inside site root folder, and here you see it. So likewise, we can utilize web jobs for all the long running background tasks or any processing that we need to do it in our web apps. Deployment slots, as I was telling earlier, that we have option for deploying our application into multiple slots. As of now, we can deploy into a staging slot rather than directly deploying it into a production slot. The advantage we get out of it is we can test it in a staging slot before promoting it into the production, but that doesn't mean that once we deploy it in production and we get any issues, it makes it pretty easy to swap between both the slots, the staging and the production. So for example, if I have deployed in staging slot, I tested it, I found it working fine, I promoted it to prod, and I see there has been issues going in on my website. But what happens is, when I have swapped from my staging to production, the version of my application which was running in the production slot is actually swapped into the staging slot. So I can again swap it back to bring back my old code from the staging slot into production, so that I can fix the version which was running in the production and it was breaking. Each slot has its own app host name because they are actually different websites which are running in the same server. It's not necessarily the same website. It's a different slot, different web app which is running there. App content and configuration can be swapped between two slots. As I was saying, we can swap it easily. Benefits that we get is we can validate the changes before promoting it to production. All instances are warmed up before swapping, so that is critical when we are promoting directly to production. It might result in downtime because we have to bring down our app and promote it. But when we are using slots, we promote it to staging, we test it, and we just have to swap it. So it is automatically handled by Azure load balancers. It's just a flip which happens between the staging and the production slot, and bingo, and it never brings any downtime to our web apps. They always remain up. So the same thing happens if we face any issues in prod and we want to revert it back to the version which is now in staging slot. We again go and just swap it. So without any downtime, it brings back the old version. Continuous deployment, app services or web apps support continuous deployment through a variety of cloud source control providers like VSTS, Git, Bitbucket, Dropbox, and so on. Kudu, which I was telling you about, it's a troubleshooting and analysis tools which is available as part of web apps. We can use them. So I will show you that it only differs in the URL from the actual website, with only 3 characters. We add .scm into the actual web application URL to reach out to those tools, rather than, but what I have shown you was I have shown it through the portal, but we can directly go through the URL also. It is considered as a buddy site to the real Azure website web app which is running, because through it we can actually go and see what's happening in our server, what's happening in our site. Why it comes handy is because, as I was telling initially, that we don't have privilege to do remote desktop into the server where our web app is hosted. So we really don't know what's going wrong if our app is not working or there are any issues. It runs in the same sandbox but in a different process. It provides command and PowerShell console. I have just shown the command console. I will also show the PowerShell console. We can view the streaming logs from there. We can download memory dumps. We can verify the environment variables and application settings there. We can also see web jobs, functions, webhooks, deployment hooks over there, which I am going to show it in the demo. So this was the Kudu website, and you will notice the URL here. My application URL was omaha.mtgtest.azurewebsites.net, and for Kudu it is .scm.azurewebsites.net. It is installed by default for any web app that you deploy in Azure, so you don't need to do anything extra for getting it set up for you. So when we reach this Kudu tool, we land up into this page where we can go and see all the app settings. It calls basically REST APIs, which touches the virtual machine and return backs all these settings for us. We can go ahead and we can see the current processes that are running. So we see there are a couple of W3, WP processes which are running over there. We can see webhooks. As of now, there is no webhook to attach to our web app. We can see if there are any web jobs. I see this will refer to the one web job which we have hosted. So this was the one which we have created through the portal. So likewise, whatever web jobs we have, we can see it here. Going into the debug console, this was the command console that I have shown before to see the files. We can execute any command, prompt commands that we execute in our Windows servers normally. We can also go ahead and get PowerShell console, which gets connected to the virtual machine on where web app is running. We can also go ahead and see the process explorer, which shows the processes which are running, which we have earlier seen through REST APIs. It reflects the process explorer, which we can see through task managers in our Windows server. We can profile those processes if we want to analyze any of those processes, because these are the processes which are running our web app and web job. We can see the properties, under which credentials it's running, what resources it is consuming, and so on. We can download the dump, and we can see the log files. Likewise, we can stream logs. An important thing to note here is it actually has authentication built into it. So it uses the admin credentials that I have used to log into my Azure subscription, which is also the admin on my web app. Without those credentials, I cannot log in, because otherwise, if it's open, then anyone can access it. So it's authenticated, it's secure. It's taking time. So that's pretty much about Kudu. There is a new preview feature which is available under web apps, where we can directly go and edit our files within the portal. It reflects a UI which is quite similar to Visual Studio Code. When we deploy our web app, we get an option called App Service Editor, we click on a preview and we can actually go through the file system and edit the files. I will show you how we can do it. So for all the .NET developers, whenever we are installing Visual Studio, if you want the Azure tools also to be downloaded with your installed with your Visual Studio, do remember to select the option for Azure development there. It actually sets up everything that you need to develop Azure Web Apps. So once you install Visual Studio with Azure Development Toolkit, then you will get all the options to create different types of Azure projects. I'm going to come to this, that how we can access our deployed web app in the Visual Studio. This is I have shown it to you just now that we have published it from Visual Studio. We can create our app service within Visual Studio. Visual Studio also supports remote debugging our web apps. Once we host our web apps in Azure, we can remotely debug through Visual Studio. I will quickly show the demo on that. So I have one of the controllers here. I'll put a debugger here first of all. Then I'll go to Server Explorer. I have already logged in into the Visual Studio using my live ID, which is administrator on my Azure subscription. So once I go to the Server Explorer, under Server Explorer, when I go to the Azure tab, I do see all the different services that are available under my subscription. I will go to App Service. This is my resource group, so it orders based on the resource groups. Since both of my web apps are in the same resource group, they list under the same resource group. This was the web app under which I have hosted my code. I will quickly right click it and I will get, we see different options here. We can stream logs, we can start profiling how our web app is working. But what I am going to showcase now here is how we can debug our app. I will click on Attach Debugger. It will start attaching my web app to Visual Studio and it will open a new instance of my web app so that we can remotely debug it. It won't be able to start the remote debugging because we have to explicitly go and enable remote debugging from the settings. We'll go inside app settings. I have set it earlier as enabled already, but by default remote debugging is set to off. We can enable it from here and we can choose the Visual Studio version from where we are going to debug it. I will go to home. Oops. I will click on About, it goes and stops there. Let me refresh it. I don't know, it's jumping off it, but what I was trying to show is like if I edit the message there, it will be reflected on the website. But you can see here from the URL, it's running on the Azure and I can debug my application there. I have another application here, set it up on my machine, which is a web app which connects to a SQL database which utilizes Entity Framework Code first to create a database instance. So earlier when I have demonstrated deploying a web app from Visual Studio, it was a plain web app which was deployed. Now I am going to deploy a web app which utilizes a SQL database, and I can deploy actually my database also as part of the web app. So before I publish it into Azure. Let me show you how it looks like. It maintains a basic to-do list. I can go ahead and create something, and it basically goes and creates a database in the backend and stores the values over there. Let me go ahead and publish it. I will use the existing one. So you are seeing here the deployment slots. As of now, this was the blank placeholder what I have created earlier, but I can create different slots here and I can choose which slot I want to deploy it into. I will select the website. Since there is no other slot, this is the first time I am deploying this, so that's why it's not giving me an option to select any particular slot. By the time it gets deployed, what I would like to quickly cover about Application Insights, which is a extensible performance management service for web developers. We can monitor our live applications using it. It basically captures all the telemetry information from our live running applications. It supports .NET, Node.js, and Java. It can be utilized as standalone also, not specifically for a web app, but we can utilize it for our on-premise or a service web app which is hosted in other clouds. But I'm going to demonstrate it as part of the web app. It has very minimal impact on app performance when we are integrating app insights into our app, because tracking calls are not non-blocking and they are batched, so generally they run in separate thread and they really don't hit the application performance. Using Application Insights, we can monitor the request rates, response times, dependency rates, failure rates, exceptions, the page views and load performance metrics, AJAX calls that were made to our app, user and session counts, performance counter, diagnostic trace logs, and so on. So here how it works. When we integrate our Application Insight with our web app, it monitors each component of our web application, and it keeps on logging into its telemetry information, which includes alerts, and I will show you in the portal how we can see all the telemetry information, but we can utilize it by capturing the telemetry information from App Insights, and we can generate analysis reports using Power BI on top of it, or we can utilize it in our Visual Studio to identify what's going wrong in our application, and so on. So my application is running now. The problem here is that when I was publishing my application, I didn't specify the connection string, because when it was running locally, I have configured my web config to run against local database and create it. But when I'm running it, when I published it, I didn't explicitly specify the connection string. So it's failing on SQL Server error that it cannot connect to it. So I will integrate App Insights into it and show you how we can see what's happening in our application. So if you have installed Azure SDK as part of the Visual Studio installation, you will also get an option called Application Insights in the context menu for your project. Once you go inside that, it will, if you have not configured Application Insights for your web app, you can go ahead and configure it for your web app. So it starts with free tier, but depending upon how much data you are going to capture and what all you are going to do with that, the cost may go up. So for demo, I will start for free. I can create a new resource for my app. New resource. App Insights is also a resource under the Resource Manager template. So that's why I'm going to create a new App Insight resource. it says allow application insights to collect data beyond 1 gigs per month. I want it to be free for me. So ensure that when you are doing it, you choose whatever is best for you. And under my free tier, what I got is 1 gig per month data, $2.3 per gig if I cross 1 gig, so which I have opted not for, that it should not cross 1 gigs for me. And it retains the data for 90 days that is captured from my web app. Let me go ahead and register it. So it's configured. The last piece that I'm going to configure is that it should also collect traces from my diagnostic logs. So here I have configured app insights for my web app. Let me go ahead and publish it once again. Since I have deployed it earlier, the profile got saved, so I am utilizing the same profile, publishing profile, to publish it. I will go to the portal. So before we can start seeing what App Insights logs, I will go ahead and enable all the settings for App Insights, that it captures all the required logs that I want. You will scroll down, you will get an option called Diagnostic Logs here. By default, all the logging is switched off, but we can go ahead and enable whatever type of logging we want in our application. I will go ahead and enable application logging. I can select up to what level I want. It should be error, warning, information, and so on. I will keep it till warning. I don't want to store it into a blob. I want it to retain into the file system itself. I don't want web server logging. I want detailed error messages. I want failed request tracing. Let me go ahead and save it. So here I am, I'm all set with my App Insights configured for my web app. Let me quickly go to the App Insights. So first time when we are doing it for any web app, we need to install an extension for our web app. So that's why you can see here that we need to instrument our ASP.NET app. Let me quickly set it up. It takes fractions of seconds. In the meantime, I will go ahead and refresh these pages, requests again, so that I can see few requests. It's still running. We'll see the telemetry information starting flowing very soon. So it has started recording different metrics for me, like server response time, page view load time, and so on. Let me go and search what's happening. I can go ahead and filter it based on the time range for how much time frame we want the data. Is it for last 30 minutes, last hour, last 4 hours, last 30 days. Maximum is we can take out this data for last 90 days because it is not retained beyond 90 days. So I'm going to keep it as is, and or rather I can keep it last 30 minutes, and I will go ahead and update it. I can go ahead and filter it here based on the event types that I want to see in my logs. I'm only interested in what exceptions are happening in my application that it's not allowing it to load. So here's the exception that I got. Same way we can add app insights into all our applications and we can monitor them and we can see what's happening. Let me quickly go ahead and fix my application so that it connects to the correct database and starts working. I'll click here on settings. I'll go ahead in settings. I see that my remote connection string was not set. I will go here and connect it. Oops. So when we were publishing before, we didn't opt it to create a SQL Server database with our web application. Go ahead and create it. I will create, select existing. Oops. So when I was creating the profile, what I missed was I wanted to create a database and update my connection string. So once I set up my app service, I'm going to click on explore additional services. I'm going to add my SQL database over there. I will create a new server. I will select the service plan, I will select my resource group. So now when it is deploying, it not only deploys my web app, it also deploys a SQL Server instance for me. It creates a database for me inside it and it connects it for me. So by the time it comes up, so you can see the different requests that I have sent, it logs the exceptions. That's why it was still all the requests that I have sent before. I can get it seen. I can see it logged in the app insights. By the time that comes up, my other website, let me proceed. So we can, when I was starting with my presentation, I was talking about the auto scaling and the scaling features that we get as part of the app service. So we have two options. We can scale up our web apps or we can scale out. And when we say scale out and scale up, I can quickly show it to you how it works. On the left menu, you will see scale up and scale out. Both refer to the app service plan. When we scale up or scale out, it goes and impacts the app service plan, and which in turn actually impacts all the apps which are running as part of that app service plan. So for example, why we will need to scale up or scale out our web apps is, for example, I had deployed my web app into basic tier, and then I started seeing more load and I wanted it to be upgraded, or I wanted to utilize app service in an environment. So let's say I wanted to utilize traffic manager, which was not part of basic tier. So I can go simply here and I can upgrade it. And my subscription was purchased when I was back in India. So that's why I can see all the price in rupees. But if your subscription is purchased in US, you will see all the pricing in USD. So, and it will give you a basic idea how much it is going to charge for every month. So let's say I promote it from S1 tier to P1 tier. I will just go and select, and it will go ahead and update my app service plan. It doesn't result in any downtime or as such. That's it. So my scale up, my app service plan has been scaled up. Scale out is when we want to increase the instance size, the instance count. So for example, currently my I only have one instance of my web app running. I can increase it to 1 to 10 depending upon the tier that I have used. So for example, I can go ahead and choose, let's say, 5 instances running, and I can save it. It will automatically go ahead and install my other 4 instances and bring them live. And automatically it will start load balancing between all the 5 instances without me doing anything. There is another feature known as auto scale, which we can configure so that our web apps or app services get scaled based on predefined metrics. So let's go ahead and enable it. We can go ahead and scale it based on a metric or scale it to a specific instance count. So let's keep it based on a metric. I can go ahead and add a rule that on what basis it should auto scale. I can go ahead and choose the metric name, which might be CPU percentage. If it touches 80% of my CPU utilization, it should scale up. If it is data in, data out, memory percentage, disk queue length, HTTP queue length. So let's keep it as CPU percentage for now. I can provide the time aggregation, whether I want the average of the CPU percentage to reach 80%, or minimum it should be, or maximum it should be. I can specify how we want to aggregate the metric value there. We can choose the operator value also greater, like I have chosen here that I want to scale based on my CPU percentage, and I want it to be greater than 70. As soon as my CPU utilization reaches 70, I want it to be I want it to wait for 10 minutes, and I want it to go and auto scale it. And I can go ahead and specify that how much instance count it can increase by. I can specify 1, 2, 5, 10 depending upon what I want. So let's keep it for 1. Likewise, I can go ahead and add multiple rules together, not only specific to CPU. I am also worried about memory percentage. I can go ahead and update a rule for memory utilization here. Instance limit specify the number of instances that should be there at all. Right now it's all set to 1, which is by default, because if my rules are in place, it might go and hit my cost as well. For example, if I place a rule as and when my auto scaling takes place, it might exceed, let's say, 10 instances, which I don't want. My maximum instances I want is to be 5. So I can go ahead and specify here, so that whatever auto scale rules comes into picture, it will never cross 5 instances in total. So that way my cost will be under control. I go ahead and save it, and okay, let me go ahead and give a name for it. Let me go ahead and save it. That's how we can set it up, auto scale for our web app, so that it automatically handles the different types of configurations for scaling up or down. we just covered the two different options we have for scaling, scale up and scale out. An app service can be scaled, app service plan can be scaled to accommodate changes in pricing tier as I've shown you in scale out, or changes in instance size or instance count, which we have seen. This was the screenshot of the rule that we have added. We have seen the metrics and the operations that are available under the rule. Azure Traffic Manager is a feature which is available as part of the Azure offering, which helps us in load balancing between different instances of our applications hosted in different geographical regions. For example, earlier I was telling we can have a resource group in which we can have multiple app service plans, each hosting a app instance for us. But those app service plans can actually be in two different regions, and we can set up Azure Traffic Manager to actually load balance our incoming request to either of those based on the different algorithms that it supports. The three main algorithms that it supports include performance, weighted, and priority. So we can choose the appropriate algorithm and we can divide it on upload based on that. Azure CDN is Content Delivery Network, which is a fast, reliable algorithm which helps us in delivering our content faster. Generally, it's used for all the image files or the video files that we want to host it as part of our web apps. And I will show you all these things quickly in the portal where we can configure these. Just a quick stats. Like for example, in Sanjos we have a CDN location as well as the Microsoft Data Center. So the time to hit the location or hit a web app which had a CDN configured and the web app which doesn't have CDN was almost same. The variation was only 2%. But whereas in London, where we have in the same city, we have seen variation of 343%, where time to hit through a web app which has a CDN configured was 343% times faster than the one which didn't have. So it had CDN locations are much more globally present than what we have it for Azure regions. So we can leverage it for delivering our content quickly. Coming to web app backup, under the web app menu we also have an option for backing up our web apps. We can back up our web apps into snapshots and we can again restore them back at a later time. We can, though we can back up our web apps, there are certain things which are supposed to be backed up, which includes app configuration, file content, database connected to our app. Those are actually go into and reside into a storage account and a container whenever we are backing up, including the web app settings. We cannot do it under basic or free or shared. It's supported only in standard and premium tiers. Backup can be only up to 10 gigs of size, because we can also back up our database as part of our web app backup. So it's restricted on 10 gigs. We can clone our web apps. For example, if we want to create app instances into different app service plans, we can clone our web apps, which will create as is copy of our web apps, but there are few things which doesn't get copied. For example, the app insights or the Kudu extension settings that we have seen. If we are looking forward to move our existing web apps into Azure, there is a tool available which is hosted in movemetothecloud.net website. We can download it from there and we can migrate our apps from there. App service environment provides a fully isolated and dedicated environment for running our app service in case we don't want to go up to a next level where we don't want to divide our app instances among app service plans. We want a fully isolated and secured environment for our app services. We can opt for app service environment, but it's only part of premium tier, so it comes at a cost. Hybrid connection, we can it's based on BizTalk services, and it's an easy way to connect our app services to all on-premise resources behind firewall. Likewise, we can also connect our web apps to virtual networks, which are Azure virtual networks, and we can connect to our other resources within the VNet. Last but not the least, Microsoft has recently introduced a couple of testing features as part of web apps called as performance test and testing in production, which we can directly do it in portal. We can run our production tests or load test on our web apps and see the results and see how it performs. What it does is basically it runs an algorithm on the load balancing, and it redirects some of the client data on client request on our staging app, and it generates test results based on that.
It's kind of canary testing.
Sorry?
Canary testing, kind of, you're taking a segment of the population and setting them to your
Yeah.
staging environment. Is that
So
right?
it sends a portion of the request from the client incoming from the production slot into the staging slot, and it tests against it.
Very cool.
Here are the deployment slots that we can see. As and when we will keep on adding and deploying into multiple slots, it will start getting listing here. I think maximum we can have 5 slots for each web app. We can configure it, continuous deployment. I can configure it. So the app that I have shown, which was failing on the SQL Server connection, is under source control in VSTS under Git. So that's why I can choose that project. We can go and configure performance test here, but I don't have testing background, so I was not sure. I tried to understand it, but I was not. But what I understand is we can go here and we can specify our performance test, like how many requests we want to send in how many minutes or seconds, and it actually runs that load testing and it generates the reports. When I tried doing it, it failed my deployment, so I have skipped it as part of the demo. I just want to cover it, which works. So I will skip it for now. I only have master branch where my code is sitting, so I choose the master branch. Let me go ahead and click OK. So it will configure it for me in a minute. By the time it comes up, let me scroll down and show you the backup section which we were talking. We can configure our backups. We can specify the schedule on which it should back up our web apps. We can also specify on how it should back up our database. We can specify our custom domains here. If we have purchased the domain, we can specify a name or C name settings here, or we can buy a domain directly from Microsoft.
Excuse me. When you do a custom domain, does it, when you do your deploy from Visual Studio, does it deploy still to the myappname.sc.azurewebsites.net, or is it deployed to the custom domain?
No, it deploys into the Azure, but the custom domain is linked to the URL in which it gets hosted. It doesn't get deployed on the custom domain.
Okay.
Custom domain probably just is a
It's
CNAME.
just a CNAME which redirects the request into the.
Our proxy is blocked AzureWebsites.net, so it makes it fun to try and deploy to Azure, and we haven't blocked custom domains yet, so. Yeah, I have to hook up to a public Wi-Fi to be able to deploy. my
VPN
website.
into your apartment.
Yeah, it's not working very well.
We can upload our certificates here, and we can make our app services accessible over HTTPS. We can go ahead and clone our apps as I was showing. We can create a new clone out of our current web app. It will create a new app instance out of it. We can, like we created a web app in the starting, we can create a cloned web app also, like the same way. We have to specify the resource group and the app service plan, and we also can specify app settings, like what all we want to be getting cloned, for example, app settings, connection settings, and so on. This was the area which I was talking about, performance test and testing in production. I tried, but I was not one of these is in preview, so I don't know if it really works or not. I tried working on it, but anyone having testing background might be having better idea who can give it a try. app service editor, what I was showing, that it looks like how Visual Studio Code looks like. So I can open it, I can go ahead and modify my files directly in the portal and it gets reflected there. For example,
Excuse me. Can you also do it through Guru, like edit files?
I don't think so, we cannot do it.
You can.
Yeah.
You can edit uncompiled files through Voodoo and
We-
through the other things.
Like we can execute, I know we can execute web jobs and we can add new files there, but I don't know if we
You can
do it
go and
from
edit like HTML files and
Yeah.
the web config through the Voodoo thing too.
So I can go here. I can go ahead and edit my view. We can edit our codes and we can see it. Let me go and see if I can. It automatically gets saved. We don't need to click any save button on anything. As soon as we make changes, it automatically gets reflected over there. My web app is not running, so I cannot show you, but this is how we can edit the files directly into the, and it looks like similar to how we have the interface for Visual Studio Code. So when I have set up my continuous deployment, it is now connected and it will just load in a fraction of seconds. So it says my first code has been deployed and here are the details. It also supports continuous delivery, which is under preview, but we can either have deployment options through source controls directly or we can have continuous delivery here. So I will go ahead and disconnect it from here first so that I can demonstrate the other one. I will go ahead and configure it. On the same lines how we configure continuous delivery for rest of the platforms, rest of the deployments, we can do it here. We can choose the VSTS or Git or whichever repository we want. For example, VSTS in our case. I can select the project, and I can select the branch and the repository and click OK. I can select the application framework on which my application is running. It might be ASP.NET, .NET Core, Node.js or whatsoever. For me it's ASP.NET. I don't want to run any load tests for now because it breaks my code, but we can go ahead and set up the load testing here. And I want to get it deployed to a staging slot. I go ahead and create a slot here. When I select use existing, there was no existing slot, so I need to go ahead and create a staging slot here. And I click on OK. It configures continuous delivery pipeline for me automatically and without me doing anything in the code really. It will connect to my repository now and it will pull up all the code changes and it will build my code from here. And I think that's pretty much about today's talk. It was pretty long and I tried to get as much as possible into a single session, but there are still lots of things which I need to try it out. So hope you gained something.
All right, any questions for Vaibhav?
So by the way, continuous delivery is set up and the build was triggered and it was successful. We can introduce our test also in between and it works. Thank you.
All right, thanks, Vaibhav.